On Venus, the sun rises in the west, a phenomenon that is completely opposite to what we experience here on Earth, and sets in the east. This unusual occurrence is due to Venus's retrograde rotation, meaning it spins in the opposite direction to most planets in our solar system. Imagine a world where compasses point you in the wrong direction. Navigating such a planet would be a challenge, as the familiar rules of orientation would no longer apply. A place where sunsets are reversed. The sky would darken in the east, and the dawn would break in the west, creating a surreal and disorienting experience for any observer. This is Venus, our closest planetary neighbor, a world of scorching heat and crushing pressure. The surface temperature on Venus can reach up to 900 degrees Fahrenheit, hot enough to melt lead. But Venus holds an even more bizarre secret, a fact so counterintuitive it seems to defy logic itself. A day on Venus is longer than its year. Venus takes about 243 Earth days to complete one rotation on its axis, but only about 225 Earth days to orbit the Sun. This means that if you could stand on the surface of Venus, ignoring the unbearable conditions, you would experience a complete cycle of day and night before witnessing a full orbit around the Sun. How can this be? The slow rotation of Venus is a result of complex gravitational interactions and the planet's dense atmosphere. Let's delve into the cosmic ballet that governs Venus's celestial dance. The planet's thick atmosphere, composed mainly of carbon dioxide, creates a runaway greenhouse effect, trapping heat and causing extreme surface temperatures. Additionally, the atmospheric pressure on Venus is about 92 times that of Earth's, equivalent to the pressure found 3,000 feet underwater in Earth's oceans. These harsh conditions make Venus an incredibly hostile environment, yet they also contribute to its unique rotational characteristics. The dense atmosphere exerts a significant drag on the planet's rotation, slowing it down over time. Despite these challenges, Venus has been a target of exploration for decades. From the early flybys of the Mariner missions to the detailed surface mapping by the Magellan spacecraft, our understanding of Venus has grown immensely. Future missions aim to further unravel the mysteries of this enigmatic planet. As we continue to explore Venus, we gain not only insights into our neighboring planet, but also a deeper understanding of the dynamics that shape planetary systems. The study of Venus helps us appreciate the delicate balance that makes Earth habitable and underscores the uniqueness of our own planet. The Twilights of Venus, with their reverse sunrises and sunsets, serve as a reminder of the diverse and wondrous phenomena that exist within our solar system. They challenge our perceptions and inspire us to keep exploring the cosmos, seeking answers to the many questions that lie beyond our world. Venus rotates on its axis incredibly slowly. In fact, it is the slowest rotating planet in our solar system. This slow rotation is so unique that it takes Venus an astonishing amount of time to complete just one full spin. It takes approximately 243 Earth days for Venus to complete one rotation. To put that into perspective, if you were standing on the surface of Venus, you would experience a single day that lasts nearly 8 months by Earth standards. Meanwhile, Venus zips around the Sun at a relatively brisk pace, completing an orbit in just 225 Earth days. This means that while Venus takes its time to rotate, it is much quicker in its journey around the Sun. This peculiar mismatch between Venus's rotation period, its day, and its orbital period, its year, creates the mind-boggling scenario where a Venusian day is longer than a Venusian year. Imagine living on a planet where the concept of a day and a year are so drastically different from what we experience on Earth. Imagine celebrating your birthday twice before a single sunrise. On Venus, you would have 2 birthdays in the span of one Venusian day. This is a fascinating and almost surreal concept to think about. This is the reality on Venus, a world where time seems to flow at a different rhythm. The slow rotation and quick orbit create a unique environment that challenges our understanding of time. The thick atmosphere and extreme surface conditions add to the mystique of this planet, making it a subject of endless fascination for scientists and space enthusiasts alike. Venus's thick atmosphere, composed mainly of carbon dioxide, traps heat and creates a runaway greenhouse effect, making it the hottest planet in our solar system. The surface temperature is hot enough to melt lead, and the atmospheric pressure is crushing. The surface of Venus is dotted with volcanoes and covered in vast plains of lava. The planet's harsh environment, with its scorching temperatures and high pressure, makes it an incredibly hostile place for life as we know it. Despite these extreme conditions, Venus remains a captivating subject of study. Its unique characteristics, from its slow rotation to its thick atmosphere, offer valuable insights into planetary science and the dynamics of our solar system. Venus, with its day outlasting its year, continues to intrigue and inspire us, reminding us of the diverse and wondrous nature of the planets that share our solar system. But Venus's oddities don't stop there. Not only does it rotate slowly, it also spins in the opposite direction to most planets in our solar system, including Earth. This retrograde rotation, as it is known, is another piece of the puzzle that contributes to the unusual length of a Venusian day. Picture this. On Venus, the sun would rise in the west and set in the east. It's a world turned topsy-turvy, a cosmic anomaly that continues to fascinate astronomers. The reasons behind Venus's sluggish retrograde rotation remain a subject of scientific debate. Some theories suggest that Venus may have experienced a cataclysmic collision with a large object early in its history, throwing its spin into disarray. Others propose that gravitational interactions with the Sun and other planets over billions of years may have gradually slowed and reversed Venus's rotation. Whatever the cause, Venus's unusual rotation has profound implications for its climate, its atmosphere, and even its very evolution. Imagine a world where the sun crawls across the sky, taking months to complete its journey from horizon to horizon. This is the reality on Venus due to its incredibly slow rotation. A single sunrise to sunset cycle on Venus takes a staggering 117 Earth days. This means that day and night on Venus are not measured in hours but in months. The sun's apparent movement across the sky would be almost imperceptible, a slow creep rather than the familiar arc we experience on Earth. Despite its intriguing celestial mechanics, Venus is a planet of extremes. Known as Earth's twin due to its similar size and proximity, Venus couldn't be more different in terms of its environment and conditions. Its surface is a scorching wasteland, hotter than the hottest oven, with temperatures reaching a staggering 464 degrees Celsius or 867 degrees Fahrenheit. The landscape is dotted with vast volcanic plains and towering mountains, making it a geologically active planet. This intense heat is caused by a runaway greenhouse effect, trapping solar radiation and turning Venus into a planetary furnace. The thick clouds of sulfuric acid reflect sunlight, but the carbon dioxide-rich atmosphere traps the heat, preventing it from escaping back into space. Venus's atmosphere, composed primarily of carbon dioxide, is 90 times denser than Earth's, creating a crushing pressure at the surface equivalent to being 900 meters, or 3,000 feet beneath the ocean's surface. This immense pressure would instantly crush any human-made spacecraft attempting to land without proper protection. The atmosphere is also home to ferocious lightning storms and hurricane-force winds that sweep across the planet at speeds of up to 360 kilometers per hour, or 224 miles per hour. These storms contribute to the planet's hellish reputation. Adding to its bizarre nature, Venus rotates on its axis in the opposite direction to most planets in our solar system, including Earth. This retrograde rotation means that on Venus, the sun rises in the west and sets in the east. Moreover, a single day on Venus, from one sunrise to the next, lasts longer than an entire Venusian year. Scientists believe that Venus may have once had conditions suitable for liquid water and possibly even life. However, a catastrophic event, such as massive volcanic eruptions, likely triggered the runaway greenhouse effect, transforming it into the inhospitable world we see today. Despite its harsh conditions, Venus remains a target for future exploration. Understanding its extreme environment can provide valuable insights into the dynamics of planetary atmospheres and the potential for similar processes on other worlds, including Earth. The extreme heat on Venus is a stark reminder of the delicate balance that governs our own planet's climate. Venus's thick atmosphere, rich in carbon dioxide, traps heat from the sun, creating a runaway greenhouse effect. This process has caused Venus's surface temperatures to soar, making it the hottest planet in our solar system, even hotter than Mercury, which is closer to the Sun. Venus's dense atmosphere creates a surface pressure equivalent to being 900 meters or 3,000 feet beneath the ocean's surface on Earth. This crushing pressure, combined with the scorching temperatures, makes Venus a hostile environment for life as we know it. Imagine the weight of an entire ocean pressing down on you. That's the reality on Venus. It's a planet where even the most robust spacecraft would be crushed like a tin can. Despite its inhospitable conditions, Venus holds valuable lessons for understanding our own planet. Often referred to as Earth's twisted sister, Venus shares similarities in size, mass, and composition with our planet. Studying Venus's extreme climate and geology provides insights into the delicate balance of factors that make Earth habitable and the potential consequences of runaway climate change. Venus is often the brightest object in the night sky after the moon. Its thick, reflective clouds make it a dazzling celestial beacon, easily visible to the naked eye. For centuries, Venus has captivated observers, inspiring myths, legends, and scientific inquiry. Its ethereal glow serves as a reminder of the vastness and wonder of our cosmic neighborhood. From its peculiar rotation to its scorching temperatures, Venus is a planet of contradictions and extremes. It's a world that challenges our assumptions about what a planet can be, a celestial enigma that continues to captivate our imaginations. As we continue to explore our solar system and beyond, Venus serves as a reminder that the universe is full of surprises, and there is still much to learn and discover about our cosmic backyard.